Now let's talk about SQL injection. SQL stands for Structured Query Language. It's a language used to communicate with a database. Almost every single application that stores data will use some sort of a SQL in some way. A SQL injection will allow an attacker to potentially execute malicious queries that will lead them to create, read, update, or even delete data out of the database. So when you're making a request to retrieve some sort of a data, a query similar to the ones on this screen may appear in the background. There are two major types of SQL injection. Error-based, which is not as usual anymore thanks to new libraries, but also there is blind SQL injection, which is more likely to run into in bug bounties. In the case of an error-based SQL injection, the application comes back and tells you that your SQL query has some sort of an error in the syntax. For example, you could see it come back and say there is a syntax error near the character that you have put in. So in our example on the screen, we're making a request to example.com/some endpoint, and we're assigning the apostrophe to the ID. In the second example, we're doing quote, and so on. In case of an error-based SQL injection, the application is going to come back and let you know that the character that I've provided has broken the SQL query that's running in the background. So in this case, my SQL is coming back and saying, hey, there is a syntax error next to the character apostrophe. And you can do this in different ways. You can see them on the screen. There's an apostrophe, a quote, adding brackets or an array to the parameter, and so on. So what actually happens when you put an apostrophe? Why does this work? On the left-hand side, you can see the request, and on the right-hand side is an example query that would happen in the background of the application. So the first request here we're making is to an application, to the endpoint news.php, and we're fetching the ID 1. So this could be an article that in the database is numbered as ID 1. So in this case, we are fetching data based on the ID 1. In the query on the right hand side, we're doing all of this and we're adding the ID from the request to the end. So as you can see, the number 1 is being put into 2 apostrophes and being fetched from the articles table where the UID column is equal to 1. In the next request, we're going to add an apostrophe to our request. And as you can see in the request in the back end, the articles table with the UID column is equal to 1 with an extra apostrophe. This will actually break the query that's being ran in the back end, which will cause an error that could indicate for a SQL injection. And in the last example, we're using and to say we want to finish a previous query and also run the next query. So in this case, we're just saying, hey, the expression 1 equals to 1, which is true, and the database is not going to give us an error. So for this slide, we just want to look at what a query looks like and why does it throw out an error when we add an apostrophe. So in the next example, what we're going to do is we're going to end our previous query. This is why we add the single quote. And we're going to add the next query that's going to fetch the data that we want. So for this example, where we're doing ID equals to 1 without the SQL injection, the web application is going back and saying, hey, get me the information for the news article that has ID 1. But when we do a SQL injection, we say, okay, now that you have done this in this particular query, but also I want you to fetch the data that I want. So as an attacker, we could be looking for passwords, username, email addresses, or whatever that we're after. So in the first example, when we do a union select 1, we practically are trying to guess how many different columns exist in this particular table. So we're still in the articles table. As you can see, it's articles and the next .uid, which is the column name. We're still looking to see how many columns are actually within this table. So in this case, because we're giving the wrong number of columns, the application comes back in response and says, hey, the select statement you have given me has less numbers of columns as I expect. So there's different numbers of columns. So we add another number. These numbers could be either one, it doesn't have to be in order of 1, 2, 3, 4. It's just placeholders for us to count how many actual tables are there. It either has to be null or we have to give it numbers and not actual characters that could be mistaken for a name of a column. So for the next example, we're doing select 1, 2, and it comes back and says, hey, I'm expecting more. There are a different number of columns. We add 3, which in this case means there are 3 columns within the table articles. And those could be different columns like UID, the title, and the body of that news article that we're looking for. So because we're doing the number of valid requests, it's going to come back and says, hey, here's the data you asked. I'm going to print some random data for you. And as you can see in our fourth example, we're doing the same thing. We're closing out the query and we're saying, hey, union select 1, 2, 3, 4, which is one more column than the application expects. And it comes back and says the same thing. Hey, your select statement has a different number of columns. I can't help you with this query. So when we do this in our error-based SQL injection, we're guessing the number of actual columns that exist within that table. In this case, there are only 3. And as you can see, at the end of each of these statements, we have the dash dash plus. The dash dash usually in a SQL query means a comment, so anything after that is ignored, and this the plus sign is actually a space. So what we're doing is we're saying, hey, I want you to comment out and ignore everything that comes after my query that may be hard-coded within the code. So again, the dash dash that we have at the end of it is just to comment out and force the application to ignore if there is any leftover code from the original query. So now that we know this application for our example has 3 different columns, what we're going to do is guess for the name of each column. So in this example, we're saying, hey, I want you to select 1, title, and 3. So now that we have successfully found out how many columns exist within this table, the next thing we want to do is guess for the name of each column. Again, when it comes down to hacking, context matters. So in this case, because we know that we're looking at the articles table, we want to guess things that are related to an article, like a title, the body, ID, and so on. So in this case, what we're going to do is we're going to guess for the title. We're going to say, hey, I want you to fetch 1, title, and 3. If that column exists, we're going to get some data coming back from the website, which in the second line, you can see we're giving it a fake name. We're saying, hey, select 1, fake name 3, which it's going to come back and say, hey, fake name doesn't exist in this table. And again, on the third line, on the third example, the union select 1, 2, 3, we're doing this again to just show an example that, okay, if we give it a valid query, we return data, we see that this is actually working. And if we give it something invalid, it's not going to work. You can also force a SQL injection to fetch data from a different table. So in this case, I'm saying, hey, I'm going to guess 1, 2, 3, 4 from fake name, which is the name of the table. We're now saying, hey, I want you to forget whatever you're running into this table. So this application is working within the article table. Forget that table. I want to go after a particular table named fake name. And if that table name doesn't exist, the application is going to come back and say, hey, this fake name that you've given me doesn't exist. So for example, a valid one that would be good to look for would be the users table, when we can say, hey, 1, 2, 3, 4 from users. And if the users table actually exists, the application is going to come back and say, hey, there was more than 4 columns within this table. Now we have to go back to step 1 and figure out how many columns are within the next table that we're enumerating. If this is confusing, trust me, it's all going to make sense when we go to our lab.